Most of these passenger car diesel engines, these TDI engines, will use some form of a VGT turbocharger assembly. And what exactly is that referring to? Well, it's a variable geometry pitched turbo. So what can happen is the EDC controller can change the pitch of the exhaust passing into my turbocharger assembly. And what are some advantages of this? Well, it allows the turbocharger to build boost at a rapid rate at low speeds. So I can actually restrict the airflow going into the exhaust side to help this turbocharger come up to operating speed. Well, once engine comes up to operating speed, I don't need the turbo screaming along. Now I can actually adjust my VGT mechanism to go down to a lower boost output or regulated boost output by adjusting my guide blades in the turbocharger. So some of the components involved in the turbocharger, as you can see, is number one is the actual turbo assembly. Number two is the turbine. Number three is the guide blades. So number three are those yellow guide blades. Those are the devices that are actually changing the pitch of the exhaust entering that turbine wheel. And how are those controlled? Well, they're controlled by number four, the vacuum unit. It's a vacuum operated valve that's going to control a collar inside of there. So that vacuum unit has a connection that goes off to the engine. So the EDC controller can control when it sends a vacuum command to that unit in order to move the guide blades. So what happens here? Well, in a very low engine RPM, very low exhaust flow, the guide blades are rotated in a more of a horizontal position. That way when the exhaust is coming by, they're coming by a small little opening, which helps speed the velocity of the air coming up into the turbine assembly to get the turbocharger up and spinning a lot quicker. Well, now the engine's up to RPM a little bit, the turbocharger is moving along. Now what happens is those guide blades change their horizontal position and pitch downwards. They will in turn open up the gap like you see we have on this left-hand side here to what we call the high exhaust flow range, where we have a larger column of air is able to make its passage into our turbine assembly to help control the speed of the turbocharger. And that's how our variable vane turbocharger is able to change the pitch that it has to the turbine wheel. All right, what components help control this boost pressure? We know the EDC control unit has control of this VGT assembly, but what is it looking at? There's different variables that come into play in order to know what to set the boost pressure at. So those are things like the map sensor, the control unit itself, and the wastegate bypass valve. All those parts working together to ultimately set the boost pressure to control what the turbocharger speed is set at. So how can you validate, how can you confirm and test that the VGT assembly is working properly on your turbocharger? For one, we can grab a scan tool and actually plot some of these actual values. In this particular example, we're going ahead and we're going to plot a couple different values. We're going to look at engine RPM, we're going to look at the desired boost, or what the control unit wants the boost to be at, the actual, or what's behaving on the vehicle, and then the duty cycle that the EDC is commanding to my VGT solenoid. So we're looking at a combination of these things to determine what's going on. In this particular example, you can see we've got the VGT actuator stuck in the low speed operation. So when it's stuck in the low speed operation, it's causing the turbocharger to overspin, create too much boost. So as you look at these plot lines, you can see the desired boost is set at a certain point. The actual boost is climbing and climbing and climbing out of the range of the desired boost level. So this particular one, we have a problem with the VGT assembly. We do ultimately set a fault code, we do set an overboost code, but it doesn't always show up right away because the car is actually running out of its desired range. Now in this example, as I go up in RPM, up in load, you can see my desired matches my actual. I have perfect control over this boost in this particular example. Doesn't matter what speed I set it at, what load I set at, I'm able to follow along properly. So I know at this point the vehicle is repaired and I have good control over my VGT mechanism.